Hello, dear students. Today we'll be discussing about electricity, the full concepts and what are the uses of electricity and how it helps us in our daily life. So we'll be discussing about electricity. This is the complete note. Uh, First of all, we will discuss about the units that are being used in electricity chapter. So we use ampere to indicate current. That is, for current we use ampere. The unit of charge is coulomb, and the unit of energy is joule. We also have resistance, that is ohm. Unit of time is always in seconds, and unit of voltage or potential difference across circuits are measured in volt or V. And unit of power is watt. You can also tell it as the joule per second. That means joule per second can be also named as power or watt. Okay. uh, so the units are ampere, that is for current, coulomb for charge, and unit of energy is joule. Unit of resistance is ohm. That is the resistance, that is the criteria that the quantity that tries to stop current. That means the more the resistance, the less the current. And the unit of time is second, and the voltage or potential difference is measured in volt, and the unit of power is watt. Okay, and now we'll be discussing about mains electricity. So what is mains electricity actually? uh, Mains electricity, understand that identify the hazards and electricity, including the frayed cables, long cables, damaged plugs, water around sockets, and pushing metals object into sockets. Okay, so what is mains electricity? The source of electricity in our houses is called mains electricity. That is, the electricity we use at our home is known as mains electricity. That is the main source of power. And electricity meter, that is electricity meter, the meter that measures the electrical energy we consume in our house, is called electricity meter. That means that the amount of electricity we use per day or in a month, that is shown in electricity meter. And by showing this meter reading, we pay our electrical bills. And the next one is a fuse box or consumer unit. That is the box that contains all fuses and circuit breakers in a circuit is called a fuse box. That is, we have already seen in our house that we all have a fuse box in our houses that controls all the circuits in a house. That means in any circuit, if the current goes high, the circuit breaker or the fuse melts, and it incompletes the circuit, so that the electrical appliances and other devices are remain safe. They keep as safe, and so that a fuse box helps us in prevention of that is electrical accidents. Now, ring main circuit. What is a ring main circuit? That is wires that leave the fuse box are hidden in walls or floors around each room. These wires are connected to form the ring main circuit. Individual equipments are connected to these circuits using plugs. It consists of three wires, that is live wire, neutral wire, and earth wire. That is, ring main circuits are the circuit that are inside the wall. That is, we have connections of electricity that is inside the walls, so they form a ring main circuit. And it always is a form, that is a live wire, neutral wire, and an earth wire. Okay. So we'll be learning about what is earth wire, neutral wire, and the live wire really is, how the what are the purpose of each wire in an electrical component. So these form a ring main circuit. That is the electrical box we have, the switch box we have in each room. They form a ring main circuit. Okay. Now let's see about what is live wire. The wire that contains the electricity all the time is called the live wire. That is, this wire always remain live. That is, it always contains electricity. If we get in touch with this wire, we might get shock, or we will surely get shock, electrical shock. Now, what are neutral wear? Neutral wear, the wear that usually doesn't contain the electricity, but when it is connected with the live where it also become live. The neutral wire completes the circuit. That is, the purpose of neutral wire is completing the circuit. That is completing the completing the path, so that the electrons can flow from one terminal to the terminal, and it does not actually contain the electricity. But when it come in touch with the live wire, when neutral wire come in touch with the live wire, it forms, it also becomes live. That is, it also starts conducting the electricity as well. Well, the next one is earthware. What is earthware? The earthware usually has no current flowing through it. It is there to protect the user from appliance develops a fault. Okay, so what is actually the purpose of earthware? It usually protects the user from having or from getting an unexpected shock or electric shock, so that the user is safe to use the electrical appliances. And that is why every electrical appliances uses either earthware or a fuse inside the socket, so that it prevents the user from getting unavoidable shock. Okay. The next point is electricity is very useful, but it can be dangerous if it is not used safely. Okay, we know electricity have many uses, and if we does not have the correct use of it, or if you cannot use it properly, it might become dangerous to us. In which way? The following hazards that increase the chances of severe and possibly fatal electrical shocks are. Okay, let's see what are these. These are mainly frayed cables. Any damaged insulation can expose live wires. Okay, frayed cables, any damaged insulation can expose live wires. Okay, frayed cables means the wire that is broken in between, or there is a fault in a wire. So when it is connected with the power supply, this might can give you a severe electric shock. Okay, if the wires are long, that is the second point, long cables, as they are more likely to get damaged or trip people up. Okay, so long cable, that is, if you are using a long cable, these might get bind with the user and can trip him up. Okay, this is a disadvantage of using long wire cables. So long wire cables is usually dangerous if these get attached with you and you get topple over. That's why. Okay, the third point is damage to plugs or an insulating casing in any mains operator devices. That means if your devices is broken in some part, or they are badly damaged in some of the parts, that device is not actually safe to use until it is repaired. Because if there is any fault it develops, uh, the device might create a severe accident to the user. So if the device is broken or if it is damaged in any of the side or any of the places, make sure you repair the device and then you use it on electrical supply. Now, the fourth point is water and electric sockets are mains operated devices. That is, we know that water is a very good conductor of electricity. So when water come in touch with any device or any wires, this might be also dangerous to the user, as this might create a severe shock as well. Okay. Now, pushing metal objects into the main sockets. Okay, pushing metal object into the main sockets is usually only a problem with every young children solved by using socket covers. Okay, so usually the children, the underage children who might not have developed the mental skills, uh, with a playing hand, they might put electrical metal pins in the socket. These also might can create a severe shock to the children as well, because we know metals are very good conductors of electricity. So if any metal pin or metal object is put into the main socket, that will conduct electricity, and these might harm the user or the children playing with some sort of it. So using socket covers is safe, because nowadays the children are really rough, and and at any time they can put the metal pins in the socket, and might create a chance of accident. So using socket covers might solve this problem as well. Okay, the next session is understand the users of insulation, double insulation, earthing, and fuses. Okay, so what is insulation actually is? Insulation, some appliances are cased with insulators like plastic rather than metal to prevent user from receiving shock. This casing is called insulation. So basically, insulation means covering the metals with plastic so that the user is safe from preventing user is safe from receiving any shock. So the plastic is a good insulator. It does not conduct electricity, and this is safe to use as insulation material. What is double insulation? Okay, some appliances are double insulated. What is double insulated actually means? As well as their wearing being insulated, the outer casing as appliances is made by an insulating material. This means that there is no chance of an electric shock from the casing. Double insulation is often used in electric kettles and power tools like electric drills. Okay, drills. So what is, as well as their wearing being insulated and the outer casing. So what is double insulation? That is, we have two-way prevention of getting shock. That is, its wears are also insulated by plastics, and the metal casing, the casing that is that is supported by the device body is also protected by the plastic. That is, plastic is used both as in the wear and in the body of the device. So there is a double way insulation, double way protection that prevents the user from receiving any unavoidable shock. So this is known as double insulation. And what is earthing? Okay, now earthing, many appliances have a metal casing. Okay, the appliances that uses metal casing, this should be connected to the earthware so that the live wire becomes frayed or breaks and comes in contact with the casing. The current will pass through the earthware rather than the user. The current in the wire is always large enough to blow the fuse and turning of the circuit so that the user is safe from electric shock. Okay, so what is earthing? Earthing means that is appliances those are made with metal casings. The live wire inside them might become in contact with the metals. So if the device is earth already connected with an earthware, this live wire that is producing the electrons will pass through the earthware so as they prevent the user from getting the shock. Okay, the user will be safe from electric shock because the earthware has taken the extra electrons coming to the surface, and the earthware prevents the user from getting the shock. Okay, so earthware is really beneficial for the appliances that have metal casings, because anytime live wire can come in contact with the metal casings and cause a severe electric shock. Okay, and then what is fuse? What are fuses? Fuses, how what are the use of fuse? Okay, this is also a safety device. Fuse is also a safety device, usually in the form of a cylinder or cartridge, which contains a piece of thin thin piece of wire. It is actually thin, not thin, thin piece of wire made from metal that has low melting point. If too large current flows through the circuit, the fuse becomes very hot and blows, shutting the circuit off. This prevents you getting a shock and reduces the possibility of electrical fire. One of the fault in the current is corrected, it should be replaced again. Okay, so what is actually the fuse? Why fuses are being used? Okay, so fuse is actually a cylindrical of shape. It has a thin metal wire in the middle of it, which has a low melting point. Why the thin wire have low melting point? Because if the device develops any fault, the fuse will blow, making the circuit incomplete, so that the current stops and the device is safe from any kind of damage, as well as the user. So fuses are really helpful for the device, because when a device develops a fault, or when more than necessary current flows through the wire, and the device tries to receive it, as soon as the fuse melts, the fuse wire melts, and these actually incomplete the circuit, so as they stop the flow of current. Okay, now see how does a circuit breaker work. Okay, so uh, we have seen how, if the question comes like how fuse works, that is, if two large current, you can write from here, if two large current flows through the circuit, the fuse wire becomes very hot and blows, shutting the circuit off. This prevent you from getting a shock, reduces the possibility of electric fire. One fault one the fault once this is once the fault is corrected, it should be replaced again. Okay, this might be the answer of the question. Okay, now what are electric circuit breaker? That is circuit breaker work. That means fuses and circuit breaker has similar function. When a high current flows, the electromagnet it gains in a magnetism and attract the iron catch towards it. This separated the contact and the circuit discloses. Okay, so circuit breaker is actually it is installed in the calling bells we use. That is when a high current flows, the electromagnet in it gains its magnetism and attract the iron catch towards it. These separated the contact and circuit breaker discloses. Okay, so the iron that is connected with the circuit gets attracted to the magnets. Iron get attracted with the magnets, and which loses contact with the circuit, and these actually breaks the circuit apart, or these incomplete the circuit. So the device is safe from getting any electrical damage. Okay, switches. Now, switches in the main circuit should always be included in the live wire, and so that when the switch is open, no electrical emergency can reach an appliance. If the switch is included in the neutral wire, the electrical energy can still enter the appliance and could possibly cause the electric shock. Okay, so switches in the main circuit should always be included in the live wire. Because why they always be in the live wire? Because when the switch is open, no electrical energy can reach the appliance. But if the switch is not placed in the live wire, if the switch is placed in the neutral wire or earth wire, when you close the switch, or the opening switch means the connection is lost. Opening the switch means connection is lost. So uh, there still might be the presence of electrons flowing through the circuit, and these might cause severe electrical accidents. So the switches must be placed in the live wire to prevent the unavoidable production of electrons, or live wire is always live, it will produce electricity. This might cause an electrical damage to the device. So to prevent this, switches must be placed in the live wire as well. So now we have to know about the uses and relationship of power and current, that is P equal to VI. That means power, that is power equal to IV, current multiply voltage, and apply the relationship to the selection of the appropriate fuses. Okay, power is the amount that prevents how much voltage or energy is converted every second. That is, I have told you earlier, that is what the unit of power is, joule per second. That is every second how much energy is passed to the electrical circuit. It is calculated using the equation, that is power in watts equal to current in ampere and voltage in volts, that is P equal to VI. Okay, and using this equation we can find out the formula, we can find out the value of current, we can find out the value of voltage too. If two of the values are given, we can find the third one using in this equation. So fuses in plugs are made in standard ratings. The most common are 3 ampere, 5 ampere, and 13 ampere. That is, the fuses are only about these three values. That is 3 ampere, 5 ampere, and 13 ampere. The fuse should be rated at a slightly higher current than the device needs. Okay, so if the device is rated with 5 ampere current, you must install a fuse that is greater than 5 ampere. If the device consumes the 2.2 ampere current, you must install a fuse that is above 2.2 ampere current. That means the fuse value must be greater than the current value of the device. Okay, so here's an example. If the device works at 3 ampere, use a 5 ampere fuse. If the device works at 10 ampere, use a 13 ampere fuse. That means the fuse value must be greater than the current value. Okay, now we'll use the equation E equal to VIT. E equal to VIT, that is energy equal to VIT. I for current, V for voltage, and T for time taken. Okay, the power of an appliance tells you how much energy it converts every second. The power of an appliance, P, tells you how much energy it converts every second. So that is joule per second. This means that the total energy converted by an appliance is equal to the power multiplied by the length of time being applied used. Okay, so we have seen that is P equal to VI. So we can write here E equal to VIT or E equal to PT as P for VI. So if you omit P, you have to write VI, or if you want to omit VI, you will write P. So this is the formula. You can use VIT, E equal to VIT, or E equal to PT. Okay. So now alternating current. Alternating current, that is the current that usually changes its direction every half turn. That is, once it will go this direction, and again it will go this direction, again it will go this direction, and again it will go this, because they're always changing their direction. This alternating current. Okay, so if the current constantly changes direction, it is called alternating current. So the current that changes direction simultaneously is known as alternating current. Okay, now mains electricity. Mains electricity is an AC supply. Okay, mains electricity is an AC supply. Okay, so the mains electricity that comes is an AC supply, with the UK mains supply being about 230 volt. Okay, these are the information that is given with UK, that is United Kingdom. Okay, so this is the current, direct current DC and alternating current AC. This is the short version. That is, direct current flows in one direction only. It will come like this and this. And alternating current will flow both direction, this way, this way, this way, this way. Okay, it has the ability to flow in both directions, once forward, another time backward. Okay, so this is how DC current goes, and this is how alternating current goes, and these are the circuit diagrams. So here we can see that the DC current flows through in only one direction. It is not changing its direction anyway. But if it changes its direction, it will be converting into AC current. Okay. If the current flows in only one direction, it is called a direct current or DC. Batteries and cells supply DC electricity, with a typical battery supply maybe of 1.5 volt. Okay. The diagram shows an oscilloscope screen displaying the signal from a DC supply. Okay, so this is the oscilloscope screen that is showing a DC current. It is only a straight line, following a straight line. Alternating current can be converted to a direct current by using a rectifier. The direct current is made uniform by a filter circuit. Okay, so alternating current can be converted to direct current by using a rectifier. Rectifier is a device that converts AC to DC supply. Okay, and the direct current is made uniform by filter circuit. Now come to the point, that is the circuit, series circuit and parallel circuit, to explain why series or parallel circuit more appropriate for the particular application, including domestic lightings. Okay, so there are two kind of circuit, that is one is series circuit, another one is parallel circuit. You can easily see here. Now come to the point, this series circuit, these are the advantages written. One switch can turn off the component and off together. That is one switch operation. That is one switch can be used to turn on all the components, and one switch can be used to turn off all the components. That is one switch operation. Okay, if one bulb or other component breaks, it causes a gap in the circuit and all the other bulbs will go off. So in this series circuit, if one component is disturbed, the whole component gets shut or the whole component is damaged. So if you damage one circuit, one of the component in the circuit, the whole circuit get damaged as well. So one thing you must keep in mind, that in a voltage supply, the main supply is shared between the components, uh, and more bulbs you add to the series, it dimmer they all become. The larger the resistance of the component, the bigger it is share of the voltage. Okay, so the voltages in the series circuit are equally shared. Okay, always the voltages in the series circuit are equally shared by the components. That is, if you use 4-volt power supply and you are having 4 components in a series circuit, each component will receive 2 volt. That is, 8 divided by 4 is 2. That means each component will receive a voltage of 2 volt. In a parallel circuit, switches can be placed in different parts of the circuit. So switch each bulb has it individually or altogether. And in this parallel circuit, you will see that it has the components have individual switches. So you can turn off and on at any devices. That is, in our homes, we use parallel circuit, that we have separate switches for separate components. That is, for fan, we have a different switch. For light, we have a different switch. Okay, if one bulb or other component breaks, the only bulb, same branch or the circuit will be affected. Okay, so uh, the thing is, if one circuit is affected, the other still works. These are the advantage of parallel circuit. That is, if one circuit get damaged, the whole circuit keeps continuing the works. The whole circuit is not affected by that one loss. Okay, each branch will have same voltage. That is, the voltage is not shared in parallel circuit, but the current will be shared as well. The voltage will remain same. If you are using 8-volt battery, all the component will receive 8 volt. The voltage will not be shared, but the current, if we use 8 ampere current and you are having 4 component, every component will receive 2 ampere current. That is, in parallel circuit, current is divided same. Current is divided equally, and in series circuit, voltage is shared equally. You must keep in mind that. Now, understand the current in a series circuit depends on the voltage applied and the number of nature of the other components. That is, the series circuit. In a series circuit, the current is same in all parts. As I told you earlier, current is not used up as it passes around the circuit. The sizes of the current in a series circuit depends on the voltage supplied to it, the number and nature of the other components in the circuit. In a circuit, if more cell is attached, the current will increase as more energy is being given out to the electrons. The more resistance it attracted the circuit, the current will get less, but the current is same in all points of the circuit. Okay, so in series circuit, all the component will receive equal amount of current and the voltage will be shared. Okay, in parallel circuit, the current varies from the one and a voltage because every section will receive the same voltage. That is the 6 volt in the battery here. This section will also receive 6 volt. This section will also receive 6 volt because the voltage is not shared, but the current will be shared as well because these will remain if 2 ampere current is used, the more resistance, the component using more resistance will receive less current and the component using less resistance will receive more current. Okay, you must keep in mind that these are the graphs that is used for a resistor and wires, a metal filament lamp and diodes. These are constant graph. You must get practiced with this. That is IV graph, that is current and potential difference. Okay, this is the graph for a resistor and wire. It is a metal wire. It is a metal wire. A graph for a metal wire. That is a frequently asked question in the exam. That is draw a IV graph for a metal at a constant temperature. That is, you will draw this diagram. If they asked you to, if they ask you to draw a IV graph, I for current and V for potential difference, you must keep in mind that. So the graph is named as IV graph. IV graph for metal filament lamp, you will draw this shape. If they ask you to draw a current or IV graph of a diode, you will draw this graph. So these are actually how the graphs work, and these are the definition. These are the definition they uses. That is okay. So first of all, resistance wires. These obey Ohm's law. That is, current I is proportional to the voltage, and the graphs are a straight line which passes through the origin and the scale. You can really see here that the voltage increases with increase of current, or you can say that the current increases with increase in voltage. That means they are obeying Ohm's law. What is Ohm's law? The law that said that the current is always proportional to the potential difference at a constant temperature. That means the temperature, if the temperature varies, the current or potential difference will also vary. Okay, now the filament lamp, this is a filament lamp. The graph is said that the filament lamp is a metal wire, but it gets very hot indeed. Okay, the resistance in the metal increases with temperature. Okay, with increase in temperature, the resistance increases, the graph curves, and the lamp reaches its working current and temperature. Okay, so when the graph curves, it reaches its working current and temperature. And now for the diodes have large resistance. When voltage is applied to the wrong direction, this is shown by a horizontal line. This is a horizontal line, is negative. But when the voltage is in right direction, forward biased, it will reach around 0.7 volt. That is the maximum value of the current is 0.7 volt. This is the potential difference, so 0.7 volt, and the resistance drops to a small value. The graph curves and it becomes steep. Okay, so when the potential difference was 0, the diodes were placed in a wrong direction, and when they're placed at right direction, it starts from here 0.7 volt, it becomes steeper. Okay, so this was actually the lecture of electricity part 1 for the students. If you have any problem with the lecture, you can comment on the video section and let me know about your problems. Okay, I hope you are clear with the lecture, and if you face any difficulty, please let me know. Okay, thank you.